I wrote this word problem based on information from my basement, especially with respect to radon gas. Most homes in Canada, here's my house represented here in Canada. Most homes in Canada have a basement, and here is the earth. And the basement is, well, subsurface. And radon gas originates from the earth and goes off into the atmosphere like so. Having a basement, however, has a tendency to trap radon gas. High concentrations of radon gas within one's basement can be dangerous. I did this test some years ago. Here are the results. I did it in February 2016. I chose to use a winter month, that way all the doors are closed and you can trap as much gas as possible and get the highest readings as possible rather than doing it in the summertime. They gave me 2 vials when I did my test in my basement, and those tests were done on February 15th. I had to leave the vials open for a time and not do any air movements at all, basically stay out of the room and let the vials do what they need to do without me creating a wind in the rooms. And I sent them off, and here are the results. The radon levels in my basement, based on the 2 vials, one was at 41 becquerels per cubic meter. This is a gas, so they had to use a volume. And 48 becquerels per cubic meter for the other one. On average, my basement has 45 becquerels per cubic meters. Little note here from Health Canada. Health Canada recommends that you fix your home if the radon level is 200 becquerels per cubic meter or higher. Obviously, I'm a little safer, but I did some renovations nonetheless. It also has another disclaimer on here, and you can pause the video and read this at your leisure. But it also mentions here, radon levels less than 200 becquerels per cubic meter still pose a risk. Further, with this information, it gave me this little paragraph here. I will try and zoom in a little bit, telling us about radon and where it comes from. Basically, it's from the earth into our basements. Based on this information, I wrote this word problem. And I wrote on here, suppose that radon gas is trapped in your basement after some renovations. I did some renovations in my basement to try and stop radon gas as well as other issues that I had in my basement. Okay, so the renovations then sealing the basement against the entry of more gas. So whatever gas is already in here is now being trapped. The half-life of radon is 3.8235 days. That value I got from this textbook, you recall from a previous video. And let's find radon. Here's radon. Radon gas has a half-life of 3.8235 days. And it emits during its decay alpha and beta particles. Using this information, I built this word problem. If the initial activity was determined to be 45 becquerels per cubic meter, again from here, what is the activity after 31 days, after the renovations have done? So the idea here, I have some radon here at a level of 45, do some renovations, seal off the basement, no more gas goes in, and none actually goes out. It's just sitting here decaying. Completely seal it off. That's the intent here. None is leaving. It's all contained. That is the intent of this word problem. Equation we're going to use is going to be, since we're looking for activity, what is the activity? Is equal to A naught e to the minus lambda t. Let's Let's make a quick list of what is given. A is the activity after 31 days, so that's what I want to find. A naught, the original activity, is 45 becquerels per cubic meter. Exponential decay, lambda can be determined by ln 2 divided by the half-life of that particular species. In our case, it's radon gas. So that becomes ln of 2 divided by the half-life, 3.8235, and the unit is days. Doing this in the calculator. Show you how I do it. It's ln of 2, so I'm going to press on ln 2 and divide that by 3.8235. Press that equal sign. That number comes to 0.181286042. Often in class I said when you do calculations like this midway of an equation, write down all of the numbers that are in your calculator. And this has units. The days is in the denominator, so it's per day. That'd be my value for lambda. T is time, and I want to make this over 31 days. How much radioactivity is left after 31 days? And I have to start over here, putting this information now into our equation. The activity after 31 days is what I want to find. That's A final. Or I could carry on, say final after 31 days. That's what I want to find, is equal to the original activity, which is 45 becquerels per cubic meter, e to the power of minus, and if there's ever a mistake made, it's because this minus was neglected. So it's minus, and lambda is this term, 0.181286042. Multiply that times the time. In our case, it's 31 days. And this also has units per day. And the days cancel out. So it's e to the power of this value, no dimensions. Therefore, E is equal to 45 becquerels per cubic meter. And let's solve for this one. Again, I'm going to use my calculator to show you how that's done. I need e to the power of x. E to the power of x function. So let me find e to the power of x. There it is there. Second function, e to the power of x. I'm going to do a multiplication with a minus sign, so I'm going to open up a bracket, put in that minus sign, and this value, 1.181286042. Multiply that times the 31. Close that bracket and press equal. So e to the power of this term is equal to 0.003625122. Multiplying that times the 45, it then is equal to, I already have the number in my calculator, it's just a matter of saying multiply by 45, and that's equal to, there's my answer, 0.163130496. And the only units that are left over, because the days canceled out, is becquerels per cubic meter. The last thing that we need to do is round this to proper significant figures. Here's a good opportunity for a review. Significant figures originate from a measurement. And this value here of the half-life is a measurement. I took it from the textbook, but somebody measured it, and it has 1, 2, 3, 4, 5 significant figures. This one is also a measurement done by the testing agency. And they gave it to me to 2 significant figures. They could have done more, but they gave me a value of 2 significant figures. And this is a counting number, 31 days in a calendar. The only ones that count for significant figures are the measurements, this one and this one. I can't go any greater than the least significant figures in one of these measurements, and that one is this one, 2 sig figs. Since the measurement, the least significant figures that I have in the measurement is 2 sig figs, I need to round this to 2 significant figures, and that is approximately 0.16 in the unit becquerels per cubic meter.